From the previous video, we have learned about waves and their properties. And by this video, I'm going to talk about the types of waves. We can clearly identify mainly three types of waves. Right, the main two types out of that, transverse waves, longitudinal waves, and the other type is called torsional waves. Right, when we discuss about transverse waves, these waves are occurred by vibrating particles. Right, so I can demonstrate the occurrence of transverse waves. By this toy, I'm going to teach you or demonstrate to you how the transverse waves are occurred. In transverse waves, we have to move our hand up and down, right? The hand movement is up and down movement. But the wave, look at the wave. Wave is propagating to the front. That means this is the direction of the wave and the particles are moving up and down, right? Take a clear look at that. As this. So we can identify the direction of the wave, the direction of the movement of energy to the front, and also the particles are moving up and down only, right? So when we discuss about the longitudinal waves, so our hand movement is to or fro, to the front and to the back. Right, so we had to give a jerk, just a jerk. By this toy, it's difficult to demonstrate it, but what is happening here in longitudinal waves, these particles are come together as compressions and spread apart as rarefactions. As I have mentioned, in the occurrence of transverse waves, the particles are moving up and down, and the hand movement is to the same direction, and the wave movement propagation is to the front. And by this, what we can understand is the movement of particle is perpendicularly to the movement of energy. Always it is 90 degrees. Movement of particle is perpendicularly to the direction of the energy. And when we go to the longitudinal waves, and the particles, the hand movement is to, as shown here. These particles are coming together as compressions and setting apart as rarefactions, compressions. And the whole movement is done in the wave by compressions and rarefactions. In a wave, energy is transmitted, and here energy transmission and the movement of particles, both of them are to the same direction. Here, mechanical waves, the transverse waves are again categorized as mechanical transverse waves and electromagnetic waves. Remember, in electromagnetic waves, particles are not moved. No involvement in particles, but an electrical field and a magnetic field and the movement of the wave. There are combination of three things in here. We'll discuss it in another video. And here in the mechanical transverse waves, these are occurred with the particles, that means related to particles, solid, liquid, or in gases. Here, water ripples, waves of strings. And longitudinal waves, as an example, we can give the sound waves. Right? So, as a comparison, we can again summarize what we have discussed here. Particle movement is perpendicularly to the movement of the energy in the wave. Particles and the movement of the energy both are to the same direction. Right? So these are the main, and there are two types as mentioned here, mechanical and electromagnetic. These are the main differences in between these two. And also torsional waves occurred as a twisted movement when there is a coiled spring if we coil a spring and release, it has a twisting movement, then such vibrations, such waves are called torsional waves. Right? So most importantly, we should be able to compare these two types. Right? So I think that's enough about these two, and we'll meet again, and thank you very much.